My name is Francois Lascelles. I'm in the office of the CTO at PingIdenty. I've been doing API security for roughly 17 years. And API security is what we're going to talk about today. And I've got with me Tyler.
Yeah, thanks, Francois. Happy Wednesday, everyone. I've spent the last 3 years working for a really small startup that wanted to tackle some of the complexities of securing APIs. And it was great. We just got a lot of validation from Gartner. This company was actually acquired by Ping last year. And Gartner just came out with a report on API security, basically saying everyone's using a web application firewall, everyone's using an API gateway, and we're still seeing a wealth of breaches happen. And that's because we've seen a massive increase in both the sophistication and velocity of cyber attacks targeting APIs. And this is because digital transformation initiatives powered by APIs are opening up a whole new set of attack vectors that hackers are equally as excited about. Oftentimes you'll hear many nefarious actors in the world refer to APIs as digital buffets, right? I'll take a little bit here, I'll take a little bit there, and I'll go out and no one will know. And that's because...
Yeah. Oh, yeah.
And that's because oftentimes these attacks are coming from authenticated users. When you do a post-mortem on many of the recent breaches you've seen, you find a few things in common. One has to do with the lack of visibility. And I mean visibility from two different perspectives. One, visibility into where all of your APIs are. If you don't know about an API or don't know what's connected to it, or if it's connected to the internet, you can't really protect it. So that's the first aspect of visibility. The second aspect of visibility is understanding what's happening on your APIs after authentication has occurred, after that bearer token was accepted. So we spent the bulk of 3 years really thinking about how do we address that visibility problem. And the second one goes to is most API attacks today are going undetected because web application firewalls, which do a great part of offering that foundational security, weren't built to look for attacks coming from authenticated users. So how do we get visibility into these attacks? And then ideally, how do we block them and prevent them from happening? So I'll pass it back to Francois now.
Thanks, Tyler. Okay. I'm not sure what I'm doing wrong with this. I'm going to use the keyboard. So Tyler talked about a visibility gap. And if you look at the latest Gartner report that just came out a couple of weeks ago, that was one of the top conclusion or call to action, if you want. So this report says, discover your APIs before attackers discover them. And I think that this is mapping really well a concern that we find is very common to a lot of people that we're talking with. A lot of customers we're talking with are telling us they're just not confident that they have the complete picture of what the APIs are. Which has been confirmed by a survey that was conducted last year. And why is that? Well, how could you not know about all of your APIs? So shadow APIs is an example, right? You've got a team somewhere that is building an application. They're deploying an API that really is considered to them an implementation detail, right? Nobody knows about it except for maybe a couple of Scrum teams. That's what I would call a shadow API or an API that's operating in a cloud somewhere that is completely bypassing whatever security best practices that you have in place in your organization. And all forgotten versions. I mean, you can all imagine how that happens, right? You're going through, your API is evolving over time. And that old version sticks around for a little bit because it's needed for backward compatibility. And then gradually over time, you think it's gone, but we've seen examples where these old APIs stick around and they fall off your radar and eventually somebody finds a way to exploit that. So the other visibility gap that I want to talk about is API silos. And so we're in 2019 now, right? A lot of organizations have gone through a couple rounds of implementing API stacks, right? API management. Some of them started with an SOA stack that turned into an API stack, and then another department, deploy their own API stack. Maybe you do an acquisition. So maybe you've got a little bit of NGINX here, a little bit of IBM there. And each of these API stacks will give you visibility onto their APIs, but those things are inconsistent, right? They will not show you things that can be very easily mapped together. They have maybe slightly different metrics. So you're not getting a full picture, and that is a visibility gap. And then the last visibility gap that I talk about here, and one that Tyler was talking about, is the attack in progress. If you look at these breaches that have been that happened over the last few years, there are a few high-profile breaches. One of the things that they all have in common is that in all of these cases, the detection of the attack took months, if not years, and in many cases, years, right? The Marriott
Google
thing
was
last
3
year.
years.
Yeah, Marriott was 4 years.
Yeah.
It's extremely long, which is to me just another way of saying that these attacks are actually not really detected, right? Somebody will stumble on something and say, oh, looks like we've been attacked for the last few years, right?
And there's no shortage of talent or budget at Google or Facebook to address these things. It's that they're using the best tool sets, and the best tool sets today, for the most part, aren't adding that last kind of layer of visibility to what's happening after the authentication has occurred.
So there's clearly some types of attacks, some types of breaches that are not stopped by what we call foundational API security. And we're not saying that foundational API security is not important. We're not saying replace your API gateway, replace your authentication with what we're doing. We're really talking about augmenting security here. But we talk, there's two main topics here. One is visibility. The other one is the threat detection and the protection. So when it comes to visibility with PingIntelligence, PingIntelligence for APIs, which is the Ping product that we're talking about here, the ability of PingIntelligence for API to give you that added visibility comes from the ability of PingIntelligence to attach at various different API traffic collection points, if you want. So PingIntelligence for API, you can hook it up to NGINX, which is, an obvious one, right? In NGINX, the most popular web server out there, sees a lot of web traffic, and just by extension, NGINX sees a lot of API traffic. So whether you're using NGINX as a load balancer, whether you're using it as an API gateway, you can use our integration with NGINX to start collecting that metadata. But you might have APIs, God forbid, on something that's not NGINX, right? Something that's going over a different API gateway or on a cloud front or something like that. So because PingIntelligence can hook up at all these different collection points, we maximize the reach of the API visibility that we provide, and we collect metadata from all these different points, and we normalize the insights that you get from these different sources of API traffic. And the other thing is that PingIntelligence for APIs looks at your APIs from the perspective of looking at your traffic. So you're getting, for example, a list of APIs that's inferred. They're effective APIs. They're APIs that are actually we're seeing on the network, as opposed to maybe a catalog of APIs that your API management vendor would be showing you, which maybe 50% of those APIs are not actually active, right? So we're giving you an effective API type of visibility. I think that everybody in this room is already well aware of the importance of API security, but we're all working with stakeholders that sometimes need to be convinced about the importance of API security, right? A lot of people would be challenging you. Why do we need API-specific security, right? We have security in our application. We have application-level security that we're implementing. We have all these tests that we're doing. And one of the ways that I like to explain that to people is that hackers use your APIs outside of your app, right? I've talked about these APIs that for a lot of people will be considered implementation details for their application. They're not considering their API as an entity that's externally visible necessarily. And if you don't look at your API outside of your app, from a security testing perspective, you're greatly limiting the the different things that you can do with these APIs. And hackers don't do that. They just skip the app layer. They go straight at your API, and that allows them to, they get a freedom to poke around and look for vulnerabilities. And that is a massive security testing blind spot that a lot of enterprises are unfortunately facing today. So here's a recent example, Landmark White, which is a property valuer, the main property valuer, or was the main property valuer in Australia before this breach. And here's an example of an API that completely fell through a crack, right? There was an API that was originally designed to be really an internal API. And the whole concept of zero trust was maybe not implemented here, but somehow this API became accessible in the outside world. And the outcome or the unfortunate result of this hack was that property valuation details and contact information was leaked. Reputation was damaged. Landmark White was working with the 4 big Australian banks, and when this became public, banks were really quick to distance themselves from Landmark White because by extension, the bank's customers' information was being leaked. The bank customer bailed out of Landmark White, the CEO resigned, and the company is a bit in a disarray right now. So here's a real example that happened earlier this year. So, and there's a lot of APIs issues that look like that. They were completely lack of authentication, right? But authentication by itself is not good enough, right? It's not enough to issue tokens and validate them at runtime. Obviously, you need this thing called authorization. And this is another category of API attacks that we've seen all over the place. Many examples. USPS was very high profile at the end of last year, but T-Mobile, Verizon, and a whole bunch of API attacks really fall in that category where, you've got, in this case, okay, an OAuth token that's validated at the edge coming in, and then unfortunately, all you need to get to the API is that token. And somebody was, in the case of USPS, realized that they could access anybody's resource as long as they had a valid token. And users hackers are users too, right? They can get valid tokens, they can get a valid account. So there's absolutely nothing stopping them from doing that. So data exfiltration, account takeover is a massive blind spot for a lot of APIs out there. And I think one of the reasons that we're seeing this is that it's just not always clear whose job it is to do authorization, right? A lot of API gateway implementations expect that the authorization happen behind, downstream from the gateway. A lot of API gateway implementations expect that the job of the API gateway is to validate a token, propagate the identity downstream, and make sure that, and expect that the downstream service is going to be responsible and is going to do a great job at doing that authorization. Maybe the downstream service expected the gateway was going to do that in this case. So that's a common pattern. Another blind spot is the stolen token. So never mind the fact that hackers are users too. Hackers will find ways to get tokens that actually should belong to different valid users. They will exploit weakness at the user side, for example. Users are gullible and they get tricked into phishing attacks. Users reuse passwords, for example. Those are all vulnerabilities on the user side that allow an attacker to inject themselves into an OAuth handshake, get a token that was meant for somebody else. And then once that token is in the hands of the hacker, they use that to get data. Even if you got authentication and authorization done properly, now you got a hacker that can get data that's not meant to be for them. And then stolen credentials, right? Because of password reuse, hackers go on a dark web, they get collections of credentials, and then they bot spray that onto an OAuth authorization server, and maybe they get 1 or 2% success on that, but that's still, in some cases, hundreds of tokens that can then be used to leak information or to grab information from the application. And it's not just the user credentials. The application, you saw earlier this year that study that was showing that in GitHub, there were, I think, hundreds of thousands. Was it hundreds of thousands?
It was hundreds of thousands.
In
6 months of monitoring.
Of API keys and tokens that were just, in clear on a lot of these repos. And just in general, client applications are just really, really bad at keeping secrets. And when you publish an API, the client application is something that you have zero control over, right? Your API can be called by a client that's gone through a registration, some vetting and stuff like that, but you don't control the client application. It lives and it operates outside of your API. So you really can't trust the client to keep secrets, and that it is leaving you exposed. Default credentials, we talked about password reuse, remote access Trojan, things like Mimikatz. Those are all ways that hackers get credentials that they can then go to an OAuth authorization server, get some tokens that are meant for somebody else. So another blind spot. So if you can't trust your own tokens, what are you supposed to do, right? How are you supposed to protect yourself if you're not confident that the tokens are coming in and those API calls are what they are supposed to be? So beyond API access control, these are the API security gaps that we've talked about. So what we call foundational API security has a number of blind spots. So because hackers are exploiting the API outside of the app, they look for outside the app scenarios, things that are not tested for, things that allow the hacker to do something malicious with your API. A lot of, and I was the developer for one of the security API security gateway called Layer 7. And like a lot of other vendors in this category, we did some really, really sophisticated things that allow people to protect the APIs. But if you think about who in your organizations have the necessary skills and the necessary knowledge to configure those things, there's just not that many of those people, right? We're talking about people that understand your API, that understands how your app works, that understands security, how your API infrastructure works. And I'm sure each of you are thinking about that guy or that girl in your organization. And you're all thinking, I wish I could clone that person because they're so busy. That human factor is a bit of a limiting factor when it comes to implementing API security and really getting the most out of your API gateway, for example. And then lastly, API gateways and other tools like WAFs are real-time security focused, meaning that an API call comes in, I look at the API call, I look at various things. I will look up maybe rules outside of the gateway. I will look at attributes for users. I need to make a decision in real time. Should this be allowed or not? But some attacks can't be detected by looking at one single API call. You need to look at a trend in order to be able to identify things. And then the other thing that I was talking about is external vulnerabilities, right? It's not fair to expect your API security to be able to stop things that are not really vulnerabilities on the API itself. It's a vulnerability on the user. It's a vulnerability maybe on the client application. Maybe it's a downstream vulnerability, something behind the gateway. So through phishing, insider threat is on the rise, right? So you've got hackers that are users too. The insider threat is a big problem. Clients can't keep secret. Bearer tokens. Bearer tokens are subject to replay. And there are standards that are coming that will, in some cases, allow us to do subject confirmation, but that only addresses really a subset of the use cases in which you need to secure APIs. So those are all external vulnerabilities. So how are we going to mitigate these persisting vulnerabilities? And this is where PingIntelligence for API comes in. We're talking about API cybersecurity. So PingIntelligence for API is really about an AI-powered API modeling. So you're feeding it API metadata, and it constructs a machine learning model for your APIs. It does threat detection, it does blocking, And I'll get a little bit more in detail about the machine learning aspect of it. It provides decoys, and it provides API insights that are unified across an heterogeneous environment, right?
Yeah, I think we should always be skeptical of buzzwords in the cybersecurity world is ripe with them. The one that gets a lot of attention now is zero trust, but I think that's actually quite a good thing. And I encourage people to think of PingIntelligence for APIs as kind of the first iteration of zero trust to protect all of your digital transformation initiatives around APIs. Because essentially what we're doing after we built these per API behavioral models is making the assumption that any connection at any time could turn malicious at a moment's notice. So we don't care if that's an insider who's stealing small amounts of data over longer periods of time, if that's a hacker who's hijacked an OAuth token, or somebody in your B2B API ecosystem that is potentially doing something nefarious inadvertently. A lot of times we see the nuance of API misuse and abuse be quite tricky in identifying what is an actual threat and what's good traffic. And that's essentially what PingIntelligence is perpetually making a decision about. Is this good traffic that's in line with the intended use of this API, or is this abusive traffic or bad traffic? And by doing that, we can give you insight to many of these attacks that are typically coming from authenticated users. I think the other thing to say is when you think about API security, it's the perfect dichotomy. Because as InfoSec professionals every day, we wake up wanting to protect data and limit access to systems and applications. And digital transformation initiatives powered by APIs are doing the antithesis of that. Oftentimes, we've detected some nefarious activity before, some odd activity that deviates from the normal. And you could have an InfoSec guy, an API practitioner, a product manager, and a governance professional all argue over, is this an attack? Is this an exciting new use case for an API we want to monetize? Is this something that's violating our terms of service? So getting visibility and being able to sort all that out and to just have awareness that this activity is going is really important.
So what is this about? We talked about API security gaps that need to be mitigated. And really what we're doing is we're leveraging machine learning to do that. So if you think about machine learning, it really is about you taking big data and you're using machine learning to build a mathematical model around something, right? So in this case, the big data is the API traffic metadata, right? We're looking at your API traffic from these various collection points. We're feeding this API metadata in a data lake, and we're starting to build a mathematical model for each of your API, right? And that's important because what's normal for an API is completely abnormal for a different API. So we have a per API model of what your traffic looks like when it's coming from legitimate applications. And at runtime, what we're looking for is deviations from that model, right? Because remember what I said earlier about hackers are using your APIs outside of your app. So that actually stands out from the model because when we build the models, we're building a model for API traffic that's coming from your app. So we're looking for deviations from that model. And from a security perspective, that allows us to go back to NGINX and say, hey, we predict that this token is used in a way that's not legit. You should block that token. Right? If it's not the token, it could be an IP address or a cookie or a user identity. And we're sending alerts, we're alerting you, so we're providing visibility that way. Now, the other thing I was talking about earlier is the deficit of human expertise in order to really increase the level of security that you're getting in your environment. So there's actually no human input required in order to do this. You're actually mining API traffic metadata. That data is there for you to tap into and to leverage, right? It's going to waste in most organizations. People are not tapping that resource. So it's not requiring complex configurations from a user in order to detect an attack. It's mathematics. We're building a model, we're looking for deviations, and that's how this works. So we are about to announce, Tyler, this integration with NGINX. So
we just finished the certification modules today.
Okay, good. Just right in time for this presentation. Good. So the way this works is you've got three native modules that you load into NGINX. So the way that PingIntelligence for API works, there's two main components. There's the API Security Enforcer, which shorts by ASE. So ASE is the API Security Enforcer. So that's something that lives outside of NGINX. And there's obviously the AI engine. So what these modules are doing is three modules. The first one really is about configuring the communication between NGINX and PingIntelligence for API. The second module is intercepting metadata about each API calls that comes in, and then it uses the first model to dump that information into the ASC. And then finally, the third module is when there's a response coming back from that API request, it goes back and it also correlates that metadata to the original request call. And the API Security Enforcer collects that information coming from NGINX through these modules in a way that's completely out of band, if you want, right? We don't. NGINX is known to be super performant. We don't want to mess with your performance. This is out of band. The analysis of the data that is coming in is completely out of band on another machine, and then from the AI engine, you will get the insights. We will give you a lot of reports, a lot of dashboards that give you information that we're inferring by looking at your API traffic. And then if we do predict that there is an attack in place, through the AI engine, we're going to tell the ASC that, whether there's a token or an IP address or a cookie or something like that needs to be blocked. And what's going to happen is that the next time NGINX comes in to dump something, there's going to be an update of a blacklist, if you like, which is going to automate the blocking, excuse me, of this attack. So that's how NGINX and Ping work together. So I've talked to you about using AI to do additional security, but we have one more trick. Why don't you take that, Tyler? Talk to me about
deception. For those of you familiar with the mixed martial arts discipline of judo, judo is all about understanding your attacker's or your opponent's strengths and then using those strengths against him or her. So similarly, hackers are innately curious creatures, right? So the first thing they're going to do is probe for potential unlisted or unknown or unauthenticated APIs. And we actually have some ways to understand that probing activity. We can create decoy APIs. You can think of this as almost like a dynamic honeypot, and we can sprinkle these decoy APIs throughout your API infrastructure. You can program these decoy APIs inside your own organization. You can program these decoy APIs externally. You can actually program a decoy API inside of a real API. So if a hacker touches one of these deception APIs, these honeypot APIs, we capture that hacker. We instantly identify the source, and then we give you some visibility into what that hacker was trying to do, even capturing some of the payload as well of the attack pattern. Then, of course, on the back end, we update your API infrastructure, which may be NGINX or another API gateway, to block and prevent reconnection. So you can think of this as a more proactive way to actually block some of these attacks before they happen.
Yeah, if I could just add something there. So, we talked about attacks that go on for months and years, and then using machine learning, we reduce this time, right? Like maybe to minutes or seconds. What this is really doing is flagging a hacker before the attack even started, right? In the probing phase. So now this is getting closer to real-time security, if you like. I'll let you conclude, Tyler.
Yeah, I would say it's a space I'm really passionate about. So if you have questions, we can do a little bit of a Q&A. If you're interested in gaining insight into your API traffic, we do have a free trial. As I mentioned, we're getting ready to release the NGINX module and integration there. And it's really all about two things, as Francois spent the last half hour talking about. It's really about getting visibility into what's happening on your APIs after authentication has occurred, and then being able to block and prevent reconnection when you see nefarious things happen. And as Francois mentioned, I think this is really important. We are not replacing anything in the stack today, right? We are augmenting that important foundational security that your NGINX WAF is providing today to look for many of those low-hanging fruit attacks. We are augmenting what OAuth is doing in OIDC to protect your APIs on the authentication and authorization part by giving you deep visibility, behavioral visibility really on a per API level. And so, yeah, I think that's just about it.
Yeah. Just one more thing, Tyler. I mean, you've been there with this startup from the beginning. You guys, congratulations! You guys got a lot of awards along the way as a very innovative security solution. And Ping Identity, since the acquisition, is investing additional resource into making this even better. So, yeah, good job.
Yeah, I think you can imagine too, as microservices begin to proliferate more and more, all of the east-west traffic that's surfacing within an organization opens up another attack vector as well. And as you can imagine, our roadmap, how we're thinking about all of this is if you can relate that traffic back to the API traffic, visibility into all of that is going to be really crucial to protect an organization's digital assets. And so we're certainly helping you guys fight the good fight.
And we do have 3 minutes. If anybody wants to ask a question, I would love to. So the blacklist would contain, for example, IP addresses, but it could contain tokens, like an OAuth token that has been used in a way that deviates from the model. It could be a cookie, right? Some APIs are using cookies instead of tokens. It could also be a user identity. Go on. Yeah, that's right. So I think that the token-based blocking in this case is more relevant than the IP address, right? If you think about an attacker first getting a token and then leveraging that token to do some API activity, maybe they're using 10 tokens, maybe they're using 100, but they will deviate from the model. So that I think would be more relevant. Yeah.
Other questions?
All right.
Oh, go ahead.
How do you configure the security, the content that you look at from security perspective, like for SSN or any sensitive data? Do you look at, do you have ways to not look at them, configure them in your product?
Yeah, so assuming, for example, that your API is going through NGINX, let's say you're using NGINX either as an API gateway or a load balancer, right? Maybe your NGINX is responsible for validating an incoming token and doing whatever security, authentication, authorization rules it needs to do. So we're tapping at that level. We're actually not taking the payload of API calls. We're running in a sideband way, right? We're not running in line with the traffic. We just collect the metadata coming from NGINX, like the headers, the size, how long it takes for your service to respond.
All the metadata associated with the payload.
Yeah, all the metadata associated with those API calls. We're not actually going into the data itself, to make it easier for a compliant perspective and things like that. We don't actually need the actual data of the API calls. And we do have another product, Ping Identity, though, that does look at the data and that does data-specific security for your APIs.
I think this goes back to like a WAF, right, is typically doing a point-in-time check. They are looking for a different subset of attacks than we are. So we're not going to replace your WAF. You're going to have your WAF in place to look at the payload and quickly check that and do a blink test. PingIntelligence is looking at the behavior over time, perpetually comparing that back to the normal behavior model to look for some of these attacks that are, again, coming from authenticated users. So it's a different subset of attacks that actually don't require a payload glance, if that makes sense. Well, thank you so much. Thank you, Francois.
Thanks a lot.